For more than 10 years, Die-Tech and Engineering President Bill Berry avoided buying faster high-speed and 5-axis CNC milling, opting for what he thought would be bigger gains by palletization. Pallets allow quick and accurate interchange of parts between various machines. Now that they have also implemented 5-axis, the synergy of the pallets with 5-axis is impressive.
An inherent part of the process is for us to include the palletization in the design process. And we have features that we design into the parts that we're going to build that directly mate them to the pallet in the first operation of machining the components. The palletization system that we chose was chosen because of the precision that you can move pallet from machine to machine to machine. So once you have a part mounted on the pallet, we can move that pallet from one machine to another with an advertised true position tolerance of, I think, 40 millionths. Not only can we rough the job on any machine we want to, but we can choose to balance our workload around the shop by moving the parts from machine to machine. We might have open time on a machine that's not the ideal machine, or we may want to rough it on a big, sturdy, less precise machine and finish it on a high-speed, precise machine, and we can move it around the shop without any loss of precision. The setup time is almost non-existent. You just pick the part up from one machine, place it on the other machine. It's located with a standard reference system that's the same throughout every machine in our shop, and that reference system starts from our design.
Asked about 5-axis, Mr. Berry explains their concepts for productivity.
Until we could really get into continuous high-speed 5-axis machining, we avoided the 5-axis technology. 3+2 machining has been more traditional because until recently the machine dynamics and the programming systems simply weren't capable of outputting the cutter paths or of moving the part quickly enough to adequately cut in a continuous method. Because what you would really like to do is keep the cutter appropriately approaching the geometry it's cutting with the right tool vector. You can only do that with continuous 5-axis machining. Many of the geometric features in mold and die building that are tight tolerance, vertical, sharp corners could only be accessed in a 3-axis environment with long, skinny cutters that would deflect and had to be run at feed rates so slow that the material removal rate is just unacceptable. 5-axis machining allowed us to shorten up our cutters, reach them from angles, and define those features and eliminate the EDM process altogether on exterior features and interior features.
Die-Tech's palletization paid big dividends when they added 5-axis.
The fact that we've palletized our work for many years, that we palletized our work so that we could move things around the shop, and that we defined our components in a virtual work environment, made it very easy for us to go to 5-axis machining, because 5-axis machining by its nature requires collision detection, requires knowing where the part is in order to do the proper upfront programming of the tool paths. So having the part palletized naturally allows us to simulate the machining of the part on any machine that we use without having to wait to determine where the part is going to be on the table.
Now with 5-axis machining, the freedom to quickly and accurately move between 3-axis conventional machines, EDMs, and high-speed 5-axis machines allows higher efficiency by using the appropriate machine for any part of the job. In many mold shops, a case can be made for palletizing or for 5-axis machining. At Die-Tech and Engineering, the combination of the two has proven to be a real bonus.